Hello everyone and welcome to IB Mathlogy, your gateway to 7 on 7 in IB Math. Today we'll be solving some previous year questions based on binomial theorem. This is basically part 2 of my video. In part 1 of the video I have explained everything about binomial theorem. So now let's start with the questions. So now in this question it says find the first 4 terms of the binomial expansion of under root 1 plus 5x in ascending powers of x. So let's start. Before that let me write this formula so that you can recall. So it's NC0 a to the power n minus 0 b to the power 0, NC1 a to the power n minus 2 n minus 1 b to the power 1, and it keeps on going. But we will only be focusing on the first 4 terms. So I can rewrite the given expression as power half. So if I want to write the first 4 terms, so I will start with half C0. It will be 1 to the power half minus 0, 5x to the power 0. Then again half C1, 1 to the power half minus 1, 5x to the power 1. Half C2, 1 to the power half minus 2, 5x to the power 2, and the last term, that is my fourth term, will be half C3, 1 to the power half minus 3, 5x to the power 3. Now if I will solve this half C0, so NC0 is always 1, that you can remember. And we will not be writing this 1 because 1 to the power anything is 1 only. So my first term becomes 1. Now if I want to solve half C1, I will be using NCR formula. So half C1 will be, half I am writing as 0.5. So it will be 0.5 upon 1, that is 1 only, multiply by the 5x. Now when I am coming to half C2, so half C2 will be 0.5 n into n minus 1 factorial is the formula. So I am writing according to that only, and my 5x whole square will be as it is. Now the last one is my half C3. So that will be 0.5 multiply by 0.5 minus 1, 0.5 minus 2 whole divided by 3 factorial, and this entire thing will be multiplied by 5x whole cube. Now to simplify this further, I will get 1 plus this will be 5 by 2x. The next one will be 0.5 minus 1 will be minus 1. So I can write it as 25 by 8 but with a negative sign, multiply by x square, and the last one will be 125 by 16 x cube. So my final answer will become 1 plus 5 by 2x minus 25 by 8 x square plus 125 by 16 x cube. So this is my part 1 of the question. Now let's move to the next part. Now we have to consider this expression and we have to find the expansion of the same and ascending powers of x up to the term x square. If you can see, 1 plus px is already in its simplest form. So I have to apply binomial theorem in 1 plus qx to the power minus 1. So I will be finding, or you can say writing, at least 3 correct terms in this expansion. So upon using the formula, I will get these 3 terms, minus 1, minus 2 upon 2 factorial multiply by qx to the power 2, and it keeps on going. Now if I rewrite and simplify this, so I will get 1 plus px multiply by 1 minus qx plus q square x square and so on. Now to further simplify this, I have to open the brackets and I have to find till the term x square. So I will be multiplying everything. Let me open the bracket first. Q square x. I have multiplied 1 with all these 3 terms. Now I will multiply my px. So minus p x square q plus p q square x cube and so on. So this is how I can write. Now if you see, I have x square 2 times. So I can write it, I can take x square common and I can write it as q square minus pq, and I also have 2 terms of x. I forgot to combine, so I will combine in my next step. So from this you can directly write 1 minus x as it is q minus p plus x square as it is q square minus pq plus x cube multiplied by px square. So these are my terms. So my terms including, it says up to, so I can write this as my final answer. Now we can move to the next part. The expansions found in part A and B are identical up to the first 3 terms. So we have to show that our q value is 5 by 4. So let me first write. So from A part I got my answer as 1 plus 5 by 2x minus 25 by x square, and from B part I got my answer as 1 plus p minus q multiplied by x plus q square minus pq multiplied by x square. Now if I compare both, so my coefficient of x is this in both the cases and coefficient of x square is these two. So I can compare because they both are identical. So on comparing I can write p minus q as 5 by 2 and second equation will be q square minus pq as minus 25 by 8. Now you can, because it's a paper 1 question, so you have to use substitution method. So if I want to solve, I can write my p value as 5 by 2 plus q, and I can substitute this p value in this second equation. So my second equation will be q square minus 5 by 2 plus q multiply by q, that is equals to minus 25 by 8. And when you will be solving this, you will be getting q as 5 by 4. You can solve it and you can check, and when we will substitute this in equation of p, so this is my equation of p. So upon substituting the value of q as 5 by 4, I will get my p value also as 15 by 4, although it is not asked in the question, but we are just calculating. Now if you have any doubt in going from this to this step, you can write in the comment box. I will give you the entire solution. Now we can move to the next part. Now in this, the expression this with p 15 by 4 and q as 5 by 4 can be used as an approximation for this. This was the first question. Now what we have to do, by finding a suitable value of x, find the approximation of under root 1.2 in the form m upon n. So the first important information to get from this is, in the last C part the question was to find out the value of q. So this is a hint. Anyways, answer is given in the D part. So if you got q as 5 by 4, it means you have solved your C part correct. Now if I equate under root 1 plus 5x with under root 1.2, because using this only I have to find under root 1.2 value. So from this I can first find my x. So upon solving I will get x as 1 upon 25, or I can write x as 0.04. Once I get my x value, then I can use the expression given to me, that is 1 plus px upon 1 plus qx, where p value is 15 by 4 and x I just calculated as 0.04, whole divided by q value is 5 by 4 and x value is 0.04. Now if I further solve this, I will get 115 upon 105, that is upon simplification is equals to 23 by 21. And the question was to write the answer in m by n form. This is my m by n form. It means my m is 23 and my n is 21. Now let's see the second part. Now consider the approximation for root 5 by 2, and we have to explain why the approximation of this is not as accurate as approximation of root 1.2. So let's first take root 5 by 2. So I can write this as root 5 by 4. So I can write this as 1.25. Now if I again compare this with my question 5x, so I will be doing the same thing which I did in the D first part. So upon solving, I will get my x value as 1 upon 20. And while solving under root 1.2, I was getting my x value as 1 upon 25 from, you can check D first part. So from D first part, I got x as 1 upon 25. And from this, we are getting 1 upon 20. So now we can say that 1 upon 20 is greater than 1 upon 25. Therefore, the approximation of root 5 by 2 is not as accurate as the approximation of root 1.2. So this was the entire question. Now we can move on to the next question, where we are given with some coefficients and we have to find something. In the expansion of under root this, the coefficient of x to the power 6 is 5120. So this is given to us. We have to find the value of q. Now first of all, let me rewrite this. So I can write it as minus power half. Now since I will be using the general term formula, so I should take q to the power minus half common, so that I can make my one coefficient as 1. So I made this as 1. Now I will be using the general term expansion, that is NCR a to the power n minus r multiplied by b to the power r. Now my a according to this is 1 and my b is minus x square by 2, and my n is minus half and r will be r, as I have to find that. So if I write the general term expansion, so I will be first writing minus this. Now this will be minus half CR 1 to the power anything, we don't have to write even this, minus x square by q to the power r. Now the coefficient of x to the power 6 is given. So I can first take out x values. So this is my x to the power given. So I can equate it with x to the power 6 because this is given to me in the question. So upon equating, I will get my r value as 3. Once I get my r value, I can substitute into the question. It means if I put my r value as 3, so I am getting T4 term. So this will be, I am just substituting r value as 3. So it will be minus x square by q to the power 3. And this entire thing should be equals to 5126 multiplied by x to the power 6. Now we just have to simplify this. So if I solve, I can copy this first, q to the power minus half. Now on solving this, I can apply NCR formula. So I will get n minus 1 as minus 3 by 2, n minus 2 is minus 5 by 2 divided by 3 factorial, and I have x to the power 6 will be cancelled. So minus 1 upon q whole cube. So that should be equals to this. Now I have to again solve this. So if you solve this entire, you will get minus 5 by 16. So I can copy it here. So it will be q to the power minus half minus 5 by 16 multiplied by 1 by q cube as 5126. Now we just have to rearrange and simplify. Now upon rearranging this entire thing, I will get 5 upon 16 q to the power 7 by 2, and I can equate this with 51. Okay, my apologies, it was 5120, not 5126. You have to correct it earlier also. So if you solve this, now you have to use GDC. So it will be q to the power 7 by 2 will be equals to 16384, and upon using GDC you will get q value as 1 by 16. So this is how we will be finding out the value of q. Now let's move to the last question. The binomial expansion is given to us as this, where n belongs to positive integer and k belongs to q. So we have to find the values of n and q. So again we have to use NCR formula. So if I try to expand this, so I will be writing NC0 kx to the power 0. In this question I am not writing 1 to the power 1 or 1 to the power n minus 1, anything. Kx to the power 1, NC2 kx square. Now I will not be writing after this because in the question I have values given till x square only. Now if you compare this with the given expansion, first I will simplify this. So this will become 1. My NC1 is n multiplied by, so I can write it as n factorial upon n minus 1 factorial multiplied by kx plus n factorial upon 2 factorial multiplied by n minus 2 factorial k square x square. Now if I compare this with the given term in the question, so I will be writing k square x square and so on. Now if you see, this term is equals to 9 by 2 and this constant term is equals to 15. Now I can write these. So if I want to first expand, so it will be n into n minus 1 factorial upon n minus 1 factorial, that is equals to 9 by 2, and n minus 1 n minus 2 divided by 2 factorial is 2 only, n minus 2 factorial is 15. So this will get cancelled out, this will be cancelled out. Oh, there was a k also. So I got my nk as 9 by 2, and from here I got n square minus n by 2 as 15. So I can simplify this. N square minus n minus 30 is equals to 0, and on simplification I will get n minus 5 into n minus 6 as 0. So I can write my n value as 5 or a 6. Now we have to check for both this 5 and 6. So if I put this 5 in n into n minus 1 by 2, I should get 15 as my answer. But you can see that upon solving this, we are getting 10. So we have to reject n is equals to 5. Now let's check for 6. So it will be 6 into 6 minus 1 by 2. That is giving me 15. So I have to accept n is equals to 6. And if I substitute this n value here, I will get 6k is equals to 9 by 2. So my k is coming as 3 by 4. So my answer will be n is equals to 6 and k is equals to 3 by 4. And that's all about solving some past year paper questions. If this video helped you, please give it a thumbs up. It genuinely helps IB Mathlogy reach more students like you. Subscribe and hit the bell icon so you never miss a video. And drop a comment below. Tell me which example was most useful, or you can request any question you want me to cover next. Good luck, you have got this. See you in the next one.